Hello everyone, for today you have the second part of Bash programming. This is when you will also manage files, such that, for example, you have the read command, such that you can get here the name of the file that you want to delete, and you want to have it displayed on the same line, so you will have to deny the insertion of the new line by having this -n. Then you will have to provide the name of the file, and you also want to have the Y option, whether you want to remove it, and the N option, whether you do not want it. Okay, so this means that based on the interactive response, so this is why you have this -I, whether it's yes or no, you will delete your file. And at the end, you just mark it that this was their decision. Okay. Also, what you can have is, instead of having that quote at 45 degrees, you can have x to be equal to an expression where you can add, where you can multiply, divide, okay, or subtract, and you can have your answer with a dollar in front, the dollar of x. You can also have a new variable y, and you can store it as being your x. So as you can see, you don't add a dollar in front of it, you just have x, and you can have another operation, and in the end you can obtain your result again with a dollar in front. Or what you can do is to have it between the round braces, and you obtain your result without XPR in front, or you can have this dollar and you can have it between square braces, okay? As well as when you want to compute the result between square braces, you also call it with a dollar in front. What you can do also with files is that with -d you can check whether it's a directory, -f whether it's a file, -e is to check whether it exists. Also, you have the read, write, and execute permission with -r, -w, -x. You also have to check the length, for example, with -s, whether it is greater than 0, such that you put it between square braces, okay, and you will have this space, then you have your option, you've got another space, your argument, and then you've got a space afterwards. Okay. For example, you can also use the switch case. So you will have to interpret the value of your variable, this dollar of var, and then whether it is value 1, you will have some statements which you will have to execute. And you see that you have this double series of semicolon. Then you've got the value 2, and you've got your statements, and this one is for the default case. So no matter if value 1 wasn't matched, value 2 wasn't matched, then you enter this case and you've got your statement. As well as this case will end in the reversed version, which is ESAC. Okay, case is written like ESAC. Okay, so for example, you want to have script program, and in this case, .ch program, you have your bash code, and you want to read a number from 1 to 10. Okay, you read it, and you will have to have the case and to display which is the value which was read. So it means that we have case, we get a dollar of x, which was read, and now whether it is 1, you will have to display that the value of x is 1, and you add 2 series of semicolons. Then you do the same for 2, for 3, for 5, until 9. You can also add an option like this one, between 0 and 10, and then you say that it's a wrong number. Or what you can also do is to have this default option, and then you will say that this doesn't belong to any category. As well as you have to close your case, and it ends in ESEC. Then we have the loop. So the loop will start from expression 1. Then you've got, it's exactly like in C, or you have it in Java. So you have the default expression, which is evaluated. Then you also have the expression 2, okay, which has to be verified such that you can execute the block. which you've got here, the statements. Then you see that after for you have this do and done, such that you have a series of expressions, okay, these statements, instructions step by step. At the end of executing your statements, you will have to execute the expression 3, and then in order to repeat this whole body, you will have again to check this expression 2 whether you should enter the body of this 4 or not. So for example, you read here a number, you read x, okay, you have it on the same line, and then you've got a sum. And you start from I to be equal to 1, you want I to be less than x, and you have the value, okay, with a dollar in front. So this is similar to pointers, okay, you get the value and you have the dollar in front. Then you will have to do inside sum, you see that you have the let, and you say that your sum will be equal to the addition between the value, the previous value of sum, to which you add this 1, and this means that at the end you need to increment I, and then you have to check again whether you should repeat the loop, such that you should have the value of I to be less than the value x which was read. In the end, you will have to say that the sum of the first x numbers, okay, these x numbers, is equal to the value of dollar of sum. Okay. There is also the until statement. So we have until, there is an expression, and you have do done, such that you have a series of statements. So now inside bash, you can read again a number x, and then you have the echo of counting down, meaning that you will have until you have your x less or equal than 0, you will have to display the value of x as well as you update it, and you put this dollar in front, and between the round braces you get the value of x, out of which you subtract 1. And then you do the sleep, and then this one is simply repeated until it is less or equal, so until it will be equal, in fact, to 0. Okay. Also, when using strings, you can get the length when you've got this hashtag in front. You can also get a position, so you have, based on a substring, you have the position and you get it from that part, that point onwards. Then you can also have for that position, you can get the length of those characters. So you apply position, you've got your substring, and for this substring, you can also have length. So here you have st as being a series of numbers from 0 to 9. And in this way, with the dollar of the curly braces of the hashtag of st, it means that it will display which is the length of your string. So it will be 10. Also, you can get it from the 6th number onwards. So this means that from here you see that 0 is on position 0, okay, 1, 2, 3, 5, and then we've got 6. So from 6 onwards, knowing that you start counting from 0, you will have this substring. Okay, and also you can have the length such that based on the substring until 6, you have this 2. So you will have to get the 2 characters, okay, which are after this point. So you will have the starting point, and then you have your substring. Okay. Also, what you can do, you can go through the file names inside a certain directory from which you execute this script, and you want to have the name, okay, without any path. So you have the base name of your file. Then you want to do a transformation such that everything that is in uppercase from A to Z to be in lowercase a and z, meaning that you will have to have the echo of the name. Then you apply the pipe, so this one will in fact return the name. But upon what you have here as an output, you will have to do the transformation. And now you will have to check whether your name is different than what you've got with the previous version, so whether the base name is different than the name in lowercase, then you will have to rename it, so you will have to use the mv command in Linux. Okay, so the old name, f name, will become equal to the new name. As you can see, if is followed by your condition, so you put it between square braces. These arguments are also separated by spaces, and in the middle you've got your comparison criteria. Then after if, you've got then, and it ends in fi. And everything is placed inside this for loop. So you've got the for followed by do, and you end in done. And in the end, you can have the exit 0, which is similar to return 0, like in C, that the program was successfully executed. So for the first exercise, what you will have to do is to write a shell script. And in this one, you just receive the file name. You want to check whether the file exists. And whether it exists, you want to create a copy for it such that you have the same name as before. You add the back substring, as well as you have the current date. Okay, and you will have to check whether the backup file exists or you want to replace it, as well as you will have both files, both the original file and the one ending in back. Let's see over here. Okay, so you have the bin bash. Okay. What you need to do is to read this name of the file. So you have the echo. Don't want to insert any new line. So have enter file name. Okay. After it, you will have to read the file name. Then you will have to check if inside it, if you have this file that exists. Okay, so we should have it $$ of f name, and you add these spaces, so you have if space, then you have your square braces, you've got another space, and then after the file name you've got the space, you have then, and this one ends in fi. Okay, so inside you will have the echo saying that the file exists. Then you also get this date, okay, because I also want to add it at the end of the file. Okay. So it means that I obtain date. Okay. After that, you will see that if you do the echo of date, okay, this one will have simply the okay, so it will simply display it with day, month, year, hour, so absolutely everything. Let's see. Okay, so we can have it in this way, and then if I have again, I can do the touch, then I can have bash main.ch, add the text in. So the file exists, and you see that you get your date in this format. Okay, so you will have to get argument by argument. You have the year, month, day, okay, such that you will have the year as being equal to, okay, out of date, you have the plus, and you will have the modulus of uppercase Y, such that you obtain the year. Then in order to get the month, this is when you've got date, and you will have the plus modulus M, lowercase m for the month. Okay, and you've also got the day as being, you've got date, for which you add the modulus D, and you have them all. Okay, so let's see, the backup file, which I want to create, so I have a backup. And now my backup will have the name of the previous file, fname, for which I need to add the back and all the other arguments. So here I can have the dollar, I have the F name to get the name, and I have the dot back. Okay, such that now it depends how you want to add each and every argument. So let's say that the order is day, month, year. So you can change it according to how you write the date in your country. Then you have the backup. Okay, this is day. Then you can have month as well as you have backup. Okay, plus equal, and within you also have year. Okay, and you get them one by one. Now what I can do is to also do the echo of dollar of backup. Okay, so if I have f that takes 10, so you've got dates. This is the echo. You have the plus. So this one is. See. Yeah, this is how you do it. It is mandatory to add a space after date. So as you can see, it's really case sensitive. Okay, and in this case, you get that it's the 16th of November 2021. Okay, good. Then you need to check whether this file exists or not. Okay, if the backup file already exists, you want just to replace it. So you will have to have an if. You have the option with -e, whether it exists, of dollar of backup. Okay, so then you have then and fi. Okay, inside it, okay, we have to say whether it exists, so it will be true, whether it enters this block. So it will be that the backup file already exists. Okay, and in this case, we should also have the interactive input such that whether you want to replace it or not. So we will have this one to type y, okay, to replace it, or you have this n, okay, to quit the operation. Everything's good. Okay, so in this case we have the copy command, which depends on the interactive input of file name, my file name, the first one, and my backup. Okay, and whether it is not the case, okay, so we have this else. Now, it may be not the case, and with yes or no. So whether it doesn't exist, you really need to copy it, and you will have a copy of f name, and you have the dollar of backup. Okay. Also, okay, this is with if okay, if the file name exists, and we also have another one else, and we will have it here, echo the file does not exist. So for example, I want to do the bash main.ch, and I have t.txt. So this one does not exist because I can also have the ls. So as you can see, I have the f.txt and the main.ch. So if I have the bash of main.ch and I insert f.txt, okay, it will also create this back. And now maybe the backup already exists, so you want to replace it. It will be like an update, like a log. Okay, and it is like a log per day. And what I will want to do is to have f.txt. Then it will simply have this replacement or not. So I can write this yes, and with ls minus l, I also see what was updated. So I see that indeed it was updated, okay, based on the Greenwich time. All right, so this is what you need to do here. And for the second exercise, you just want to move some command argument files. So in fact, these are the ones that you read here. And you want them to be moved in a certain directory, as well as you want to move a file directly into trash. So you will add this path for trash. Then for your homework, you will have to manage some files which are well known, such that you will collect everything that is executable, and this one will go to bin. Then you have libraries with lib, and this one's all of them you want to put it inside the folder which is lib. Then you can have source files ending in C, CC, C++, like this, CPP or CXX, and you want it to put inside SRC, as well as the headers, they go inside INC. Okay, so you should ask whether you want to move them inside another directory than the ones by default. Okay, so it would be something like this, okay, with the interactive input. And also you have a log, okay, if you want to reverse all the moves, okay. So you need to write the reverse utility such that you just restore everything to the initial phase. Okay, as well as you've got a log, and you store this log inside the file which is called organize.log. Then you also have a statistic based on the files, how many folders were processed, how many files you've got per each category, okay, these ones which were moved. So whether they are executable, libraries, sources, or includes. And also you want to see how much time it took to execute one by one. Okay, and whether you want some input, you should also have an exit. So after a period of time, if you do not get any input, okay, based on default libraries. So this is what you will do. I will stop the recording.